Good morning and a very warm welcome here from the Beckhoff booth at the Automatica show in Munich, the leading trade fair for intelligent automation and robotics. I have a question for you. Are you ready to build the future? We live in an era of constant change, and it is more important than ever that we as engineers develop products that can be tailored to your needs. And in the next few minutes, we will show you how. With ATRO, automation technology for robotics, because the future of robotics is modular. If you have any questions, feel free to contact us via meet@beckhoff.com. We look forward to it. And even more, I look forward to talking to Thomas. Good morning, Thomas.
Hi,
good to
morning.
see you. You've been with the ATRO team since the very beginning and are currently leading our development in Austria. Can you get us up to speed? What is ATRO?
So ATRO, there we have three main components. There's on the one side base modules, so that's where you build your robot on. And there you can plug in one data channel for the customer, one data channel for us. Then you can plug in two power channels. One is for our robot, the second one is for the end effector for the customer, and the fifth one is the fluid channels you can plug in. So, and all those things go up to the TCP. And then we have our motor modules. Motor modules come in 5 different sizes and 2 shapes. So the L form is for the main robots you can build, like 6-axis kinematics. And there's everything integrated. So you have gearboxes, you have motors, you have drives, you have encoder systems, so nothing anymore in your control cabinet. And those all get connected together via our link modules, which come in different sizes and shapes to decrease or increase your working area for your robot.
And they are all combined with each other with the standardized ATRO interface, right?
Yes, that's right.
Okay, so we've presented this technology before. What has changed?
So in the beginning it was a proof of concept to see how our customers react to the modules and the whole system as itself. And now we have changed the already mentioned interface to make it more usability, to make it more usability friendly. And we changed the design to get closer to the serial production to make it easier to handle for ourselves in the production lines.
Okay, quite innovative concept, yet there are a few market competitors who have also modular approaches.
Yeah.
How is ATRO different?
So on the mechanical side, you have in the beginning, you have everything you plug in your base modules. It goes directly through the whole robot system, so no strings attached anymore, so you can move freely and with endless rotation of all axes.
Because we have no limitations due to torsion, right?
Yes, right. And then you're free to move everywhere. So that's on the mechanical side. On the other hand, it's like we come from PC-based control systems, so we have all that knowledge in that area, and so that combined with our robot system and all our other products, that's the main benefit we have.
So a lot of expertise we have from Beckhoff. Okay, so we have individual modules, integrated media feed, and endless rotation in every joint. And now we want to take a look what kind of kinematics can be achieved. Thomas, what are we seeing here in the demo?
So here we see, if you go around in the fair, you have a lot of 6-axis kinematic robots. And what we see here are 4-axis kinematic robots. So what we did, so we cut off 2 axes. That means we have a lot of dynamics more with it, and we have a lot of payload in it, but we have 2 degrees of freedom less. But a lot of our customers are happy with that anyway. And so it's good for our energy consumption with resources, and so that combined with our internal media channels and our data connections up in the front, the customer is free to do whatever he wants.
Okay, and we also have a pneumatic and an electric gripper to show the flexibility here, right?
Yes, for sure.
Okay, what else can we see here?
So here we have a 3-axis kinematic chain, so you see the robot can only move in a 2-dimensional space, but on our workflow and our working area is much bigger due to our endless rotation in our whole system. And so we have 2 link modules integrated and 3 of our motor modules integrated to move freely in the whole working space. And we have our vision system integrated, so to get more flexibility.
Ah, okay, perfect. At the front, this isn't even a robot. What is so special about this rotary indexing table?
So at the one hand, is what we show here is again our internal media channels with endless rotation and how much flexibility the customer has on the end system. And that's basically it, to show a lot of flexibility and to show the customer that we only can build one-axis systems up to two-axis, three-axis systems, so that he can do whatever he wants with
And
us.
usually it's not so easy to have like integrated fluids with the endless rotation,
yes,
right?
that's it.
Okay. I can't see any control cabinet here, so how is the robot controlled?
So in this case, all those 3 robots are controlled with one industrial computer right here. And we have one power supply for our robot, that's 48 volts. And that's basically everything you need for 3 robots or up to a big machine. So you have one main industrial PC and can control your whole machine, including all your robots you have in your application.
Perfect. Thank you, Thomas.
Yeah, you're
so
welcome.
we have individual modules, virtually endless configurations, and all integrated on one control. And that's a good point, because there's no hardware without software, and that brings me to Guido. Hi, Guido.
Hi, Ina.
We also work together in the product management for ATRO, and you're responsible for the software part. So a modular robot looks different every time. How is the configuration done?
Yeah, this is one of the important part, because you put together the modules as needed for your application. And we have a software which is 3D based and it's HTML5 based software that we use for the configuration. So we configure together the base module, the motor module, the link module. And with that, we can also have an online view, so we can go online to the control unit and see what is happening with the robot. Yeah. But the robot moves not only alone, but inside a machine. So therefore, you also need to have an integration of the cut data or the step files of the machine, which we can also import so that we can integrate the robot into the machine environment.
Okay, great. So when my configuration is done, what about programming?
Yeah, we export what we have done in the configuration to our Trinket system. And in the Trinket system, as usual for a machine, we can program the movements in PLC code, for example. For that, we export a robot instance, we export the transformation calculations, and we have the configure or the linking to the motion control. We use Motion 3, MC3, which is our new motion kernel that we use for our single axis, but also for the robots. And then we can program what is needed for the movement. If you don't want to program in a PLC, we also have the possibility for sequencing programming or sequencing. It is a more no-code programming, which we can show later with Kati. And then you don't have the structured text need that is otherwise needed in the PLC.
Okay, great. Before we go on to that, for those with expert knowledge, the new ISO 10218 has just been released.
Yes.
How do we enable our machine builders to program the robot while complying with the standard?
So the new ISO 10218 actually has some differences to the older ones, some more constraints that you have to take care. These become mandatory in the next 1 or 2 years. We expect beginning of 27. And this is, of course, our requirement specification. So with all the hardware that you've shown, with all the software that I explained, we have to make sure that we fulfill the requirements for the ISO 10218, the robot standard. And this is what we do for our customers. And there are a lot of safety functions as well in this ISO standard, like many stop functions, different stop functions, but also safe limited speed for the tool center point, but also for the exposed joints that they do have with a robot. And we can fulfill this because we have our safety PLC, which is running in software also on the IPC. So we have a centralized information and logic that we can combine all the safe positions from the axis into the safety PLC, calculate the kinematic again, and then also monitor and take care of the safe limited speed at the TCP and the joints.
Thank you, Guido. So we have different functions when it comes to configuration, programming, and all of that complying with the new ISO 10218. And now we want to take a closer look how this looks in practice. And that brings me to you, Kati. Hi, good to see you. So you've been also with the ATRO team as a developer since the very beginning, and you worked on our operating concept. How can I and everyone else operate our ATRO?
So we developed a user interface for exactly that, to get started very easily. We have all the basic functionalities like moving axis, or like movements in Cartesian space, executing programs. But on top of that, we have some really helpful features for our customers, like a preview of the X direction, where it's going to move, or visualization of our movement paths. This helps you to see how the robot is going to move in reality, and that makes programming much easier. And with such complex kinematics,
This is also what we're seeing here, right? So we have the different joints and axes, and in the middle we can see how the robot is moving, and also before the real-life robot is in movement. Okay. Do I need a Beckhoff panel for that?
You do not need one, but I mean they're great because they're made for industrial use.
Yeah. Okay.
We have a much more open approach here with bring your own device. Our user interface is a platform-independent web application. So you can use whatever tablet, PC, panel, whatever you like. You just integrate it with TwinCAD HMI, and you're good to go to control your robot with the PLC.
Okay. Would you like to show me an example?
Of course. Come on.
Perfect. We're having here our live assembly demo, where we're doing a live demo every hour and combine new configurations.
Yes. Here we are starting with a 6-axis kinematic, and we're going to make a very simple program.
Okay.
So we want to teach in some poses. That's going to look like that. We are moving our robot with hand-guided control, so I can just put it wherever I want. Let's say here, we like this position, save it, and then we are saying, like, I want to move down. And that I can do with the user interface, just moving axis set down. I can do it like that.
So now we're doing Cartesian movements.
Yes.
I guess the robots can drive way more dynamically. It's just so slow because we're standing here closely. And
that's
on
true.
The safe side.
Yes.
Okay.
So let's save this position, open the gripper, and let's bring it back to us. Let's move to a position. And here you can see the robot movement, what it's going to do.
This is in the simulation where I can see before the robot is moving.
Exactly.
Okay, and now we press play, and now the robot is moving exactly as in the simulation.
Yes, that's it. So let's save this position and say we want to execute this program. And just like that, we programmed the robot.
Perfect. So not only the mounting of the different modules is as easy as possible, but also the programming.
Yeah, exactly.
Perfect, Kaji. Thank you.
You're welcome.
So we have our ATRO interface with different functions, easy programming, and after all of that theory, we want to take a look at live applications, and that brings me to you, Tommy. Hi.
Hi, Ina.
We also work together in the ATRO product management, have your experience in hardware development. I see here a medium-sized ATRO kinematic with 2 of our intelligent transport systems, XTS. What are we showing in this demo?
Well, this is one of the demos where we show our full integration of the system. So the benefits from having everything on one controller, everything in one control system, like TwinCAD. So we have our robot here, the ATRO, in this case a 6-axis robot. Connected to the TCP, we have an EtherCAT force momentum sensor, which we just bought in this case. And then we have our 2 XTS systems. So, and then we show here that we can do position and speed control of the robot to the movement of the XTS. We even do the synchronization of the position and the movement on the fly. And on the other XTS system, we show here even a force-controlled movement. So we do position and force control. The mover constantly pushes with 8 Newton against the TCP of the robot. We are measuring this, and the robot is following this movement.
Okay. There's an extra weight mounted on top. What is the payload of this robot?
So we mounted here 7 kilos to show that it still can do very high dynamics with even like a 7 or 10 kilo payload. But for this configuration, this example, we could go up to 16 kilos with a little bit reduced dynamics. But if you need less range, for example, you can even take a link module which is a little shorter, then you have higher payload, or you reduce the gear factor of one specific module. and then you can vary the values that you need for your application.
So beside the modules itself, we have a lot of different options to give the customer maximum flexibility.
So you can 100% fit the robot to his application, anything he needs. Yeah.
Okay, how is that controlled?
It's controlled, as I said. So we generally control everything with TwinCAD and one PC. In this specific case, we use our MX system, which is a cabinetless automation system. We introduced it a few years ago already. We have an IPC, in this case IP67, like the whole system. Everything is running on the central PC. We have, on top of this, we have a main switch, we have fuses, we have the power supplies, and everything is just connected plug and play by one cable automation from Beckhoff. So you just connect one cable to the ATRO, one cable to each XTS system, then you might have an emergency stop that you can connect to a safety input module, and maybe we have a brake chopper, and that's it. So you don't need any additional hardware, no additional cabling. Everything you see here is running this machine. Yeah.
So a great application, what can be done with Beckhoff control technology.
Exactly.
Okay, besides our XTS, we also have our explainer system, where we have completely new options regarding machine designs with its almost magical floating movers. And also our ATRO has 2 arms here. Why is that so?
Yeah, this is another example of the modularity on the one side of ATRO, on the other side of TwinCAD and the whole Beckhoff system. So here you see we have mounted, we've taken our base motor module, which is then mounted here to the machine bed, or in the machine bed. We show the endless rotation, in this case on axis 1, and we just mounted 2 additional robot arms with 4 axes on top of it. It could even be like a 4, 5, 6 axis arm on top. We could have 2, 3, 4 arms, whatever the application needs. With this, we have a very compact footprint of the machine, and we can do high complex applications on a small footprint. You see with our explainer system, we're flying movers combined, and everything again synchronized on one PC, running on the same hardware, in the same real-time environment, same programming environment. You don't need to mess around with any interfaces, with dead time compensations or stuff like this. Even the vision system is running on the same...
That was my question, even that is
same
integrated?
PC, yeah, same PC, same environment.
That's pretty impressive. Yeah. Okay, what about the grippers? Are those manufactured by Beckhoff, or how do we integrate them at the TCP?
We don't, we're not planning to make our own grippers. There's many companies on the market, so we talk about to all the well-known gripper vendors. Already we talked to them, so we will provide 2 options. One option would be a ISO flange for different sizes, so you can connect any standard ISO gripper, like could be an air-driven or electric.
Therefore, we're showing our flange modules, right?
Our flange modules, and we also will have connection kits that is available for vendors of grippers, so they can integrate the ATRO functionality fully in their gripper. So they have all the internal meters, even EtherCAD could be available. Or on top of that, customers of us could buy the sets and build their own toolings, and integrate it into ATRO.
Perfect. Thank you very much, Tommy.
You're welcome.
So we have complete new options regarding machine designs and all integrated on one control. I think there was a lot of information and we learned quite a bit. Were there any questions in the chat? Perfect, Merle, thank you. Okay, first of all, thank you very much for all of your interest. I want to look who's the expert, and I think Guido will be the expert for my question. So one question that was asked particularly often is ATRO a cobot?
Oh yeah, that's really a question that we often hear, also here on the booth. The main question is, how do you define a cobot? So many customers, they expect with a cobot that it is easy to program. This is also what we can do with our robot. Then I come back to my ISO 10218, the standard that also defines collaborative applications, which means not a cobot, but the applications for collaborative action. And they define that you can make use of hand guiding control, which we support. The second thing is speed and separation monitoring, which means you have safety sensors, and when you come closer to the robot, then the speed is reduced or stands still if you come very close, which we really like because we can integrate all the safety sensors easily in our system. And the third one is power and force limiting, which means you have a power sensor, a torque sensor, a safe torque sensor, which we actually in the moment does not have, and which we are discussing whether we want to have it or not and how to do that, because we better like to avoid collisions, because with a power and force sensor you always have collisions and then you stop. But we think it's better to stop before or stop right at
to avoid the
one.
collision.
To avoid the collision at all. Yeah.
Okay.
So yes, no, both. Yeah.
Okay. Thank you very much, Guido. Okay. We live in exciting times that present new challenges. I think we should approach them with curiosity and enthusiasm. We are ready to build the future with ATRO. And you?